Today's video I would like to introduce a very nice problem of Yugoslav Mathematical Olympiad edition 1974, grade number 3. Here is the following setup. We have square root of x squared plus square root of 1 plus reciprocal of x squared equals square root of x plus 3. Okay, our goal, we are going to solve this equation. Unfortunately, this problem came out without saying which set we can solve this equation. Okay, but anyway, it's not a problem. We are going to figure out at the end of the solution. Unfortunately, I'm not going to give any hints to this problem because the information are limited here. So if you would like to give the try to this problem, go ahead, pause this video when you come back to see the full solution. Okay, by the way, just don't forget to support us with your like and subscribe. Now let's get into the solution. So before we get into the solution, we are going to determine the domain range of this equation, because there is a lot of restrictions. We should know which interval we can work on. Okay, so without loss of generality, we assume x as a real number, because the real number is a powerful set. Okay, we have x squared plus x equals x is multiplied by x plus 1 is super equal to 0. This is the first condition. I'm going through the variation table. So for this one, I will have minus infinity plus infinity. We have here x, we have x plus 1, we have the product f of x, for example. I have roots minus 1 first, I have 0. Okay, for minus 1 I have negative here, positive. Okay, from 0 from here to here is a negative. The above the point 0 must be positive, so the product must be positive here, negative here, positive here. Okay, let's call I1 as an interval. We are going to pick up only the positive interval. Okay, for this one, minus infinity to minus 1 union 0 is not included to plus infinity. Okay, so I'm going to do the second interval. We have x is different than 0. We have this condition. We have x plus 3 must be super equal to 0. Okay, it's equivalent. X must be super equal to minus 3. Okay, have the second interval as a I2 interval from minus 3 to plus infinity. So we will have intersection between this I1 interval and the I2 interval. So by doing that, let's take the point minus 1, put 0 here, put minus 3 here. For the first interval, I have from minus infinity to minus 1. So from here, this is I1. So I'm looking for the intersection. I'm going to draw the interval from minus 3 to plus infinity. So I will have from here to here. So where we have intersection, we have from minus 3 to infinity, not included 0. Okay, so the domain range x as a real number, x from minus 3 to 0 union 0 to plus infinity. Okay, 0 is not included. Or we can put x from minus 3 to plus infinity, not included 0, like this. Both expressions are correct. Okay, since we know which interval we work on, now I'm ready to solve this equation. Let's clean up this board and continue solving this equation. We have the following equation. So the next thing, I'm going to raise number 2 as a power on both sides. Now by distributing out this expression, I will get the first term as x squared plus x. The second term 2 times is multiplied by this one and this one. I will have the product of 2 is multiplied by under 1 square root. I will have the product of x squared plus x factor 1 plus 1 over x squared. So the last term, I will get 1 plus 1 over x squared by taking off this square root because of this square. 1 plus 1 over x squared. So the right hand side of this equation is giving us x plus 3 by taking this square root off because of this square. Now, so the next thing that I'm doing now, this number 3 is the same as 2 plus 1, okay? Then I will have a cancellation from the left and the right hand side of this equation. Number 1, it will be cancelled out, and also x will be cancelled out. Then the next thing, I'm going to move over this 2 which is left from the right hand side of this equation to the left hand side of this equation, and move over this big square root to the right hand side of this equation to see what's giving us. So we'll have x squared minus number 2 which I brought from the right, plus this last term which is the reciprocal of x squared. So by taking this one to the right hand side of this equation, I will have minus sign, minus 2 is multiplied by this square root of x squared plus 1 factor 1 plus the reciprocal of x squared. Then if you take a look carefully at this expression, this term is exactly written on the form of the quinary square, okay? So I will have x minus 1 over x quinary square. If you distribute this one, it's taking you back to the original one, okay? And equals to minus 2 is multiplied by this square root of x squared plus 1 is multiplied by 1 plus 1 over x squared, okay? If you take a look again at both sides of this equation, the left hand side of this equation is positive because of this quinary square, but the right hand side of this equation is negative because we have minus sign is multiplied by the positive number which is this square root, okay? Which is impossible to have this expression like this, okay? In the other word, the equation has no solution if it is written on this form. So to maintain error and make this equation work correctly, we need to give this one 0. So this one is telling us x minus 1 over x quinary square equals 0. It's equivalent x minus 1 over x equals 0. It's equivalent. I'm going to make x as a common denominator. I will get x squared here minus 1 over x equals 0. Since x is different than 0, okay, we already mentioned that in domain range, so I'm going to factor out this difference of these two squares. I will get x minus 1 factor x plus 1 equals 0, okay? That means I will have two solutions, x equals 1 or x equals minus 1. But be careful, since we have the choice, we have x equals 1 or x minus 1, you may have one solution, you may have two solutions, okay? Now we're going to replace one of those values into the original equation to check which one has a solution, which one not, okay? So let's take x equals 1, then plug it into the original equation to see what's giving us. So by doing that, this one is giving me a number 1. If I'm going to replace number 1 here, it will have 1 plus 1, which is square root of 2, plus the second term. The second term I will have 1 plus 1 over 1, which is 1 plus 1, which is 2, the square root of 2, okay? That means I have square root of 2 plus square root of 2, which is 2 times square root of 2, equals to the other side of this equation. This one, by replacing x with number 1, I will get 1 plus 3, which is 4, square root of 4, which is 2. By simplifying both sides, I will get square root of 2 equals 1. This is impossible to have square root of 2 equals 1, okay? That's mean x equals 1 is not the solution for this equation. That's mean x equals minus 1 is a solution for this equation, okay? So we'll have x equals minus 1 is the only solution for this equation, okay? Since they don't give us the set and we found the solution x equals minus 1 over integer, now we are going to choose this domain range over integer as well. So we'll have x as an integer such that we have this setup, and we'll have s as a solution, x from domain range, let's call it df, such that we have x equals -1, okay, as a solution. So I have done with this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you next video. Bye.